Hi guys, welcome back to another video. This video is going to be about the cosine rule, just an introduction to it and when to use it. So the previous video was about the sine rule, so if you aren't sure about the sine rule, go check that out. So the sine rule and the cosine rule are two different rules that you can use when trying to find a missing angle or a missing side of a non-right angle triangle. So when you can't just use the traditional sine, cos and tan. So the sine rule is really useful when you're given like a pair of unknowns or a pair of numbers, so you get two sides and two angles that are opposite each other. But the cosine rule is also useful too, and you've got to be able to know when to use each of them. The cosine rule, you have three different sides or sides that you know, or you got two sides and one unknown, as well as an angle. So that you need these four things to be able to say, yep, I can use the cosine rule for that. And when you go through examples, it will make more sense as I go through them. Okay, so this one here you can see is just a squared, so the side here squared is equal to b squared plus c squared. Take 2bc times, so remember there's like times in there, times cosine a. So the important part about this one is that your angle that you use here must be corresponding to the angle here. So you can easily write it as b squared is equal to a squared plus c squared, take 2ac cosine b, as long as these are corresponding, as long as those are linked and they're opposite each other and you're given them. So for example, you know this side but you don't know this side, this angle, then you can use this formula as long as you have unknowns opposite each other and you know them. Okay, so again, as I go through some examples, that will make more sense. All right, so you might be wondering, okay, so just like the sine rule, I might need to know how to find the unknown angle, and how do I do that? And all you need to simply do is rearrange the formula for the cosine rule. So this is what I've got here. I'm just gonna erase this for now. Okay, so I'm just going to rearrange it so I can find this angle. So for example, you know this B here, but you don't know this angle. So this is like your theta. You don't know that yet. Okay. And you know C and A as well. So I'm going to rearrange this. I'm just going to quickly rewrite it here. There we go. And I'm going to rearrange. So the first thing I'm going to do is I'm going to get rid of this negative here, this takeaway, because that tends to make things a bit difficult. So I'm just going to move it to the other side. Okay, so I'm going to have 2bc cosine A. Remember that this has to be linked together because they are multiplied. You can't split up anything that's multiplied. There goes a group. Okay, so, and then plus a squared is equal to b squared plus c squared. I'm going to get rid of this here, so I'm going to move it to the other side. So 2bc cosine A is equal to b squared plus c squared, take a squared. Okay, so the next thing I'm going to do is I'm going to divide, because again, these are all multiplied in there because they're next to each other. I'm going to divide it by 2bc so I can get cosine A on its own. So those are going to cancel out. So I've got cosine A is equal to b squared plus c squared, take a squared, divided by 2bc. And then lastly, I'm just going to find that A by doing the inverse of cosine. Okay, so I'm going to do A is equal to cosine inverse. So I put that -1 there to indicate it is inverse of b squared plus c squared, take a squared, divided by 2bc. All right, so you can use either this one or this one, as long as you know how to rearrange. Usually it doesn't really matter which one you use. But you can use either of those when trying to find a question. I'm trying to find an unknown in a question. All right, so in the next video, what I'm going to do is I'm actually going to show you a few different examples so you can help identify when to use a cosine and sine rule for that one. So if you're interested in having a look, stay tuned for that one. Thanks.